क्या हुआ?
Okay, guys. So let us, guys. I hope 5 minutes is over, so we can start. Okay. The important thing to monitor while the solution is running. Okay, guys. Can we start? Is everyone back? Can we start? Good. Fine. Okay. So the thing is, there is a lot of things which you are supposed to monitor the results. Okay. The one of the important thing is in the bottom you can see so many numbers running. 1.5404 e to the power minus 1, e to the power minus 3, e to the power minus, so many numbers are running. No, it is nothing but errors. Okay, guys, that is nothing but error. If the error is less than 10 to the power minus 6, your solution is so good. But when you see here, so far we have not reached that. Okay, definitely it will take 500 to 700 iteration, but our solution is going good. How I am telling our solution is going good is, so many matrices are there to govern a solution. So it is like, 1 minute. Yeah. So it is like, see, if the solution is converging something like this, your solution is good. If your solution is something like this, your solution is converged. If your solution is going something like that, your solution is wrong. Okay, this is good, this is converged, this is wrong. Okay, this is not acceptable. You see, our solution is going perfectly smooth, definitely it will reach a convergence after something like 400 to 500 iteration. Okay, but for 20 iteration it is taking 5 minutes, so we cannot afford to wait for 500 iteration. I'm going to stop my solution now. Okay, stop it. I'm going to wait for 2 minutes till the solution is getting stopped, else it will go like not responding. Abdullah, is the solution completed? No, Abdullah, solution is not completed, but we are stopping it. Exactly, we are stopping it because in order to reach 500, definitely it will take 30 minutes to 40 minutes because our mesh count is 10 lakhs, 1 million. Okay, we cannot wait for that much time. But see, our solution is x velocity, y velocity, and all. It went below 10 to the power minus 3. Okay, but continuity alone it is like 10 to the power minus 1, but definitely this will give a good solution but not a correct solution. Because of time constraint we are stopping it. Fine. So guys, now let's see, let assume like my solution is converged. Okay, just by seeing the residuals I cannot tell my solution is correct. Okay, just by seeing my residuals I cannot tell my solution is converged. In order to check the convergence we have something called mass balance, okay, or flux balance. So how to check the flux balance? Go for post processing, go for reports, go for flux. Now select everything, compute. It should be minimum as possible. See, it is around 10 to the power minus 6. Okay, it is 10 to the power minus 6. This indicates our solution is converged. Okay, this indicates our solution is converged. This is based on the principle of conservation of mass. Okay, it is like conservation of mass. I hope you would remember that as well. Next, go for total heat transfer rate. I'm just computing it. So this is also minus 4, but see, this is where our solution is getting lagged. Okay, this is also supposed to be minimum as possible because energy cannot be created nor destroyed. Okay, based on that conservation of energy principle, this should be minimum as possible. But here we have some value. After some 200 or 300 iteration, this will also get converged, but minus 4 is a negligible value. Okay, so that we can proceed with our solution. Okay, these convergence are very high for just 20 iteration. Okay, in 20 iteration we are getting this much convergence. This is very good. Now we are moving to post processing. Okay, I close that. It is writing the solution. Okay, open the workbench, close this, open the workbench. Okay, a project is getting saved, so we are supposed to wait. Okay, so it is saved, guys. Fine. So now what I am going to do is, okay, next what I'm going to do is I'm going for solution, go for transfer data to CFD post or results. Okay, because this is the step by step procedure. First geometry, next meshing, next solving, next result view. Now I'm going to open my results. So CFD is getting a CFD post is getting started. I'll close this. Okay, fine. So this is what we will see, guys, initially. Now I want to have my inlet. I want to have my heat transfer area. Uh, okay, so these things I need. Okay, so first I want to check how the fluid is happening. Okay, now first I want to check how the fluid flow is happening. So go for streamlines. Start from inlet. I want to have around 150 seed points. Velocity apply. Okay, so this is the flow lines, guys. So when you see, so this is how flow happens. Okay, you can even animate it. So go for animate, select the streams, make it flow. So this is how the flow will happen. Okay, you can involve so many points. 150 points I have included. You can involve 1000 points to see how the flow is exactly happening. Okay, so I will stop it. So first, what we check, see, there is flow distraction. You can see, guys. Can anyone tell me what you are observing from here? From here, can anyone tell me what you are observing? What will happen? It's not flowing through the
The
solid.
blue area will be.
Yeah. Answer is partially correct. Partially, it's good. See, the flow is coming here. It is getting distracted by the cylinder. So again, it is going like this. What happens is there is no proper fluid flow here. If there is not a proper heat flow, I mean, if there is no proper fluid flow here, heat transfer will be very less. So these areas are a major hotspot location. Temperature will be very high here. Um,
Yes, sir.
Partial fins will get heated, I mean cooled properly. In between area will not get cooled properly. Okay, so this is the first observance based on the fluid flow parameters. Okay, fine. So next, let us check the temperature distribution. So I'll hide this. Now I'm going to right click, insert contours. Okay, contours. I just want to check my temperature, so click OK. Okay, the temperature is fine. It varies from 300 to 309. Okay, so I'll do one thing. Next, what we are supposed to do is I'm supposed to create a plane. Okay, instead of simply creating a contour, it is better to create a plane so that we can have an exact idea on what we are doing. So I just want to create it based on x z. Okay, x z. Okay, so guys, I have created a plane. Now what I'm going to do is, next thing, I want to plot a velocity vectors. Okay, I want to plot a velocity vectors. First we have seen a streamline. Now I want to plot a velocity vectors, and next we will plot a temperature there. Select the plane, give apply. See, so this will show you how the velocity is distributed. Again, we can see the same thing. In between, there is no proper fluid flow. Definitely, there will not be proper heat transfer. So I'll hide this too. Now I will add contour plots. Okay, I will add contour plots. I want to have that in plane. I want to see the temperature apply. See, guys. So this is showing where the major heat transfer is taking place. So around the cylinder, because of convection, um, the heat transfer takes place, and you can see how the thing is going. I'll annotate it here. It takes heat from here. The temperature is like this. Again, it goes through that. Again, it is taking the temperature heat. Okay. So this is how the temperature distribution will be there around the surface of cylinder. Okay. Fine. Now, guys, these are just the color plots. Okay. These are just the color plots to tell you how the thing is going on. Okay. How the thing is going on. But in order to get an exact result, we are supposed to calculate the values. So go for calculate, um, go for function calculator. I'm going for area average, heat transfer area. Okay, I want to check how much temperature is there in the heat transfer area. The temperature is 308 Kelvin. Okay, the fins are in the temperature of 308 Kelvin. I want to check the total heat rejection or heat transfer coefficient. So go for wall heat flux. See, the value is the surface is rejecting 419 watt per meter square. Guys, this is the value you will calculate in your heat and mass transfer paper by analytical method. Okay, you will have a heat exchanger, you will have a fins, so many things you will have. By applying formulas, this is the value you will calculate. Here, the wall heat flux is 419 watt per meter square. Wall heat transfer coefficient is 70. Okay, H, this is the value of H. Now let me check the outlet temperature. Let me check the inlet temperature first. Inlet temperature is 300 Kelvin. So let me check the outlet temperature. So the outlet temperature is around nearly same. Okay, but this cannot happen. Okay, so in order to have a further refined value, we are supposed to run the iteration by around minimum of 500, so that there will be a temperature pickup in the outlet. So next thing which I want to check is pressure. Okay, I want to check the pressure. It is like negative. Fine. The convergence is not that much good, guys, because uh, the pressure in these areas is fine. So I'll do one thing: area average, heat transfer area. We can check for wall shear. Okay, so the wall shear, it is around 0.1. So this is the resistance offered by the fins. Okay, because of this, what will happen is there will be a pressure drop. So wall shear, so many things are there, guys. So wall heat transfer coefficient we already calculated. Wall radiative heat flux, it is 0 because here we haven't included radiation boundary condition. So we can calculate everything. So for example, if you want to have a velocity, we can calculate a velocity. But see, I am calculating the velocity for solid, so it is showing 0. Likewise, we can do so many things. Next thing is probing, guys. Okay, we have calculated the temperature, we have calculated the shear, we have calculated the heat transfer coefficient, we have calculated the wall heat flux. The important thing next is probing. Okay, what is meant by probing? Probing is nothing but I'll create a point. Okay, I'll create a point somewhere. It is 0, 0, 0. What I'll do is I'll create 0 0.01. Okay, I'll create a probe. Now what I'll do is I'll go for function calculator. In the location I'm supposed to select my point. Outline. Okay, it is mentioned as a point. Okay, guys. So I just want to calculate my values there. Point. Okay, it is not getting displayed here. That's fine. I'll delete it. Again, I'm just creating it new. Okay, so now guys, see, I have created a probe. Okay, so first we had a area average, so there is no area for a probe. I have selected a probe, automatically point 1 got selected. See, now I want to check my velocity at the point. It is undefined. Oh my god. Okay, see, the point is somewhere here, so that is why it is showing like that. Okay, so I can change the value of the point. Guys, in point probing, we have this problem. Okay, the thing is we cannot exactly place it. It will go somewhere. So this is going out. Okay, I'll put 0. What I'll try to do is I'll try to increase my y. Yeah. So now guys, see, it is exactly in my fluid domain. As you can see, it is exactly in my fluid domain. Now let me check the value. Okay. So go for calculators, point, velocity, calculate. The velocity at that particular point is 3.5 meter per second. Okay. Because this is not a parametric modeler. Okay. Said Muhammad Mansoor, it's 12. Fine. I'll end my meeting. Okay. I just want to tell you more. That's all. So the guys, see, we have placed a point in the core of the fluid domain. The velocity at here is 3.5 meter per second. Okay, you can even check the temperature there. The temperature is 300 Kelvin. Likewise, if you want to check the pressure, it will show the pressure here. It is like -4 because that is located in mid of the 4 cylinders. Because of some fluid phenomena, the pressure is very less there. Even we can consider that area as wake region. So density, if you want to calculate, we can calculate the density. It is like 1.225. Okay. So these are the important things which we want to check, guys. Okay. So I want to give a brief overview. See, we have a geometry where we created a geometry. We exported that to the mesh. We created the mesh with high quality. After that, we exported the values to Fluent where we defined the boundary condition, heat generation. We solved that. After that, we moved on to CFD post processing. Okay. In the CFD post, we saw first streamlines. After that, we saw temperature plots. After that, we saw cut section. It is like velocity vector. Finally, we saw point probing. Okay. So usually in industry, we prefer point probing. But what we do is we use something called tech plot. Okay. So there we can easily do all these stuffs. Okay. So guys, this is the CFD workflow. So this is how in industry we perform a CFD simulation. Here the model is very simple. Okay. But we perform simulations in combustor, sometimes data center racks, so many things we deal with. So these are the important steps which is involved in a CFD. Okay, guys, we have seen a complete workflow. If you have any queries, you can ask me now. I'll give you 2 minutes for doubt clarification.
Informative.
Yeah.
Sir, it was a very informative session, sir. Jibin sir,
Yes,
thank you
sir.
for
Thank you.
your detailed explanation about the CFD. I will allow the students now to, if anyone is having any doubts, please raise your hand so that I can unmute you. If someone is not able to talk, you can text your queries in chat box so that our resource person can reply to your queries. After that, I will share the feedback form which you have to fill. After that, you will be getting an e-certificate. So we are open for the question and answer session for 5 to 10 minutes. Then we can wind up the session.
Okay. Guys, finally, I just want to tell you one thing. Whatever we have seen now is just 5% of the CFD. Okay, it is simply 5% of the CFD. in order to understand the CFD completely, work on CFD, there is so many things which you want to learn. Even here, we are getting a negative pressure in between of four cylinders. Okay, even for that, we have a specific reason. So we can validate that analytically. We have so many things, but have this session as your spark. Okay, not only CFD, we have FEA. You have so many softwares in manufacturing line. So many things are there. So for students in third year, this is your right time. For students in a final year, this is your end line. For students in second year, you can start now. It's good. You can ask your questions now. Any queries,
Sir,
guys? Tell
I
me.
have a query, sir.
Tell me.
Sir, if the flow is getting disturbed like this, because of this, there will be a turbulence created before the cylinder spins. Because of that, the temperature distribution will be deviated, now, sir. So in that case, what are the chances that we can rectify this kind of errors which you have shown us? So in between the two fins, the flow is getting distracted now.
Hmm.
So, so what are the things which we can do to rectify this kind of errors?
Actually, sir, when you take any, for example, if you take a CPU or any high heat generating components, the fins will not be distributed like this. Okay,
Okay.
the fins will be staggered. So this is the reason. For example, if the fins are something like this, uh, the second line will be something like this. You would have seen this. So the
Okay,
third
okay.
line will be something
So
like
they will
this.
not be one before the other. They will be distributed like that.
It will be one
Okay.
before the other. The same problem we will face. Local hotspots will be there. It will be very problematic. But when you use something like this, it will come here, and this distance will be enough so that fluid will cross it. Okay, fluid will cross it, and fluid will directly come in touch in this way. Okay, by doing these kind of arrangements, what we can do is we can avoid this negative pressure area as well. We can prevent localized hotspots.
Okay,
Okay,
okay.
sir.
Thank you very much, sir. Thank you very
Sir, my
much.
end one
Uh,
simple question for you, sir.
Yes, sir, sure.
Sir, actually, all over the world, okay, the
Okay.
automotive of a over the world is using the 90% of a CFD only they are using.
No, sir.
Automotive
No, no.
of a companies
Actually,
like of a we can say that is a CFD. Hmm.
we cannot say
That is
90.
related to the NVH. Hmm.
Sorry, sir, I'm not getting your question.
Sir, automotive of a company, sir, automotive of a companies. So 90% of a using of a CFD software only.
We cannot say like that, sir. Actually, a
Hmm.
5 to 8 years
sir
before.
wants to ask like,
Hmm. Because this is related to the subject of a NVH, okay, sir.
Yes, sir. So actually,
This
sir,
is the subject is related to the NVH,
I,
okay, noise vibration harmony.
yeah, yeah. But here we are not dealing with the noise, vibration, and harshness. But the thing is,
Yeah, yeah, no, that is the reason for actually. Hmm.
we have so many subdivisions, sir. We have so many subdivisions. It is like CHT problems are there, NVH problems are there, crash problems are there.
Yes,
For every problem,
that is
we
the
have
DIW
separate.
parts and
Yes, sir. We
yeah,
have separate,
transfer
separate.
analysis.
We have separate softwares. If you take
So
NVH,
90% of the world, the 90% of the world are under of a CFD only, hopeful, I think. Is correct?
Now the thing is changing, sir. Yeah, previously they were using some conventional method, but now
Hmm.
majorly all the companies are going
Hmm.
for consultants, and they are building their own R&D team in NVH, as you mentioned, in CFD, in FEA, even in manufacturing they are using softwares to optimize
Hmm.
molding and all, sir. The thing is getting changed. Previously we are using softwares in a laptop, but now everything is cloud based. Anybody can use software anywhere.
That's the reason, sir. Actually, they are using of a ANSA software, sir. That is the automatic net generating for structural analysis
Yes, sir.
for
ANSA
meshing
is
purpose
nowadays ANSA is
nowadays.
getting familiarized. Yeah.
ANSA.
Yes, sir. Yes.
This is the advance of a hyper mesh actually.
Yes, sir.
So that is related to that is also deals with our CFD only.
Yes, sir. In
After
ANSA is
meshing, hmm,
ANSA is common for CFD as well. FES, sir. But here we are using ISM CFD. If you use ANSA, we remove the ISM CFD, we place ANSA here.
answer here. Okay. Yeah. Okay, sir.
Okay, sir.
So from the other countries like of USA, Japan, India, even so many countries are there. They are also using the same CFD. Right now, also they are using CFD only.
Yes, sir. Yes,
So this is
definitely.
very, very good opportunity for the student as very valuable information you have given to us, sir. And we
De-
will touch with you all
Definitely,
time
sir.
with you, okay, sir.
Sure, sir.
If
Sure.
any
Thank you.
queries from the student, we will let me know to you, okay, sir. And from management side, from our side, we are in touch with you, sir. Okay.
Sure, sir. Sure. Thank you.
Hmm? Hmm? So please
For
do
any final
support.
year project also, can we send the students, sir, for this? Can you assess them
Sorry, sir.
for
Final
final
year
year students
Definitely, sir.
for project,
Definitely.
sir.
Yeah, yeah. Sure, sir. Sure. We can help assist.
Okay, okay. Can you give any particular target for that? You have to complete this work. You only can assign that.
Basically, if a students are having their own innovative project, we can give some suggestion, advice. We can help them with that. If they are not having any projects, then we can help, sir. So how to perform a gap? I mean, research gap study. How to do everything? We can help, sir.
Okay, okay. Fine, sir. For this final year, definitely 2 to 3 batches I will send you, sir.
Sure, sir. Sure. Thank you.
Personally, we will go for some project based upon this one offer.
Okay, sir. Okay, definitely.
Thank you so much, sir. Thank you so much for your valuable time. Hope we will in contact. Soon we will conduct like the seminar and more we will learn about this subject.
Sure, sir. Sure.
Sir, this is our assistant HOD, sir, Mr. A. Rabbani.
Oh, okay, sir. Okay, okay. Fine, fine, fine. Okay, sir. Okay.
Jabin, sir.
I got it, sir. I got it.
He's our one of. Uh,
Okay, sir.
I thought
Thank
like, okay, sir,
Thank you
sure.
so much,
thank you,
I'm
sir.
Rabbani, sir. Thank you, Rabbani, sir.
definitely, sir. I'm happy to help students with this
Thank
project, sir. Definitely.
Okay, sir.
Okay. Thank you, sir.
Sir, Srinath, can we wind up, sir?
Yeah, we can wind up and please send the Google form to
Yes,
the
sir. I have shared,
student.
sir. I have shared the Google form in your in chat box. Uh,
Okay.
I'm getting few responses also.
And okay, sir, you can directly share. You can send to the group also. Okay.
Okay,
Second is
okay.
satisfied.
I will share also in the group, sir. Okay.
Okay. Thank you, sir.
Thank you, Jabin, sir. From on behalf of management, on behalf of our principal, sir, HOD, sir, and department of ISL College of Engineering, I would like to thank you for your valuable time and valuable knowledge which you have shared us for our students, especially the new generation of mechanical. With this, they will get a broad area where they want to do the research, where the mechanical is going to be further extended. So it is the right time, and you have given a valuable suggestions to them, sir. It's a wonderful opportunity for us to have with you again. So surely we'll be associated with you, sir,
Sure, sir. Sure. Thank you,
in this
sir.
journey,
Thank
sir.
you. Thank you,
Thank you.
sir.
We can wind up, sir.
Yeah,
Thank
sir.
you.
Yeah.
Thank you.